Welcome class. This is the second video on homework up to, in this case, before the ideal gas law and before the Dalton's law of partial pressures. And so again, I had that question about how do we really do this process for homework? How do we do this step-by-step process? And I know I have a process that I like doing a lot. You may have a process that you may like doing a lot. But right now, I'm going to highlight, in this case, the Avogadro's law and how I process it. So again, with Avogadro's law, we're talking about the volume and the amount of moles. So right now, V1N2 equals V2N1. And that, in this case, is a direct proportional relationship. So if I increase the amount of moles, you're going to expect the volume of that gas to also increase. And so it's going to look like this on a graph. Now let's do number 2. So number 1 is the same as number 2 almost, but number 2 goes through a different process and is a little bit more tough, a little tougher. So it says that 46.2 grams of oxygen gas occupies a volume of 100 liters at some temperature and pressure. What volume will 5 grams of oxygen gas occupy under the same conditions? And so it just says under the same conditions, so it respects that idea that we're at the same temperature and pressure. However, we got a few things here like 46.2 grams, 100 liters, and 5 grams. Now, if you look back up here, do we have any mass amount here? Not really. We don't. And so how can we get a gram amount into a mole amount? Well, that's going to have to use the molar mass. And so oxygen gas, we're dealing with not O, but O2 in this case, because that is oxygen gas. The molar mass of that's going to be 16 times 2, because the molar mass of one oxygen atom is 16 grams per mole, but since I have 2 of them, it's going to be 32 grams per mole. Okay, and how I really do this is I want to find this process to get rid of grams and find myself in moles. And so I kind of have this grid scenario going. And so what's going to happen is that I have this grid or this chart here, and right now I'm going to start in mass. So that's my mass right now. Right below it, I'm just going to put the number 1. The reason why is because there's nothing below it. It's just 1 by itself, which means I'm only dealing with 1 unit right here. However, here, I want to end up in moles, which means moles has to be what's up top. Well, what's down below is I have to get rid of it in grams. And so in this case, this can be applied to the right side, and whatever we have up here for amounts can be applied to the left side. And so it's going to look a little bit like this. I have 46.2 grams. Again, it's over 1. And I'm going to multiply it by, again, there's only 1 mole of O2 equal to 32 grams. Now what's going to happen is that gram, that unit goes away. It gets canceled out as a result. And now I'm going to be left in moles. And that's going to be our desired answer, what we want to get. So let's take 46.2 divided by 32. And what is our answer? I find that we are in 1.44. 1.44 moles of O2. Okay, so that's going to be considered N1 because that's our first N amount, our first mole amount. And again, we got to apply that same process for the second one, for 5 grams. So let's do that right now. 5 grams all over 1, that's by itself, times it by 1 mole O2 divided by 32 grams. And what is our answer? So 5 divided by 32, we have 0.156 moles. And that's going to be our N2 amount, our second mole amount. So now we have both of our mole amounts. We have a volume. I'm going to get rid of some space here, and we're going to do some problem solving. So again, our equation is going to be V1 N2 equals V2 N1. So we're taking the first volume amount, 100 liters, multiplying by the second N amount, which is this one here, 0.156. 156 moles equal to some unknown volume of volume second here, times it by the first N amount, 1.44. All right, let's get rid of some of this space here. Now, all we got to do is that same process. We just take and get V2 on its own side. The way we do that is we divide by 1.44 on both sides. And so if I divide, I'm going to find 1.44 down below here, 1.44, and this one on this side goes away. Now, so our answer for V2 is going to equal 100 times 0.156 divided by 1.44. And now our answer is going to be 10.8. 10.8 liters. And that's going to be our answer. And it should make sense because as we see with this linear relationship, if we go down in amount of moles, we should go down in volume. And we see that. We see that we went from 46.2 grams to 5 grams. As a result, I went from 100 liters to 10.8 liters. So that's how you do Avogadro's law. Now I want to talk about a few things about homework. So, a lot of us had questions about homework. Is it going to be graded? Are we going to turn it in? Are we going to have homework checks? And so I do believe we will have a homework check between now and the test, which is going to be next week, if you're hearing this on the first week of distance learning. And as for homework in terms of grading and everything, right now it's Chapter 13. I will not grade Chapter 13's homework. However, it is great practice to use for the test. Again, I've always stated that we can use we can use homework and notes for the test next week, and it's going to be very useful for you if you have this stuff completed. If you have Boyle's law, if you have Charles' law, if you have the combined gas law, if you have these graphs are going to be monumental when it comes into deciding and using conceptual questions, because this will help you out a lot. Combined gas law, there's a lot of questions about the combined gas law on the test. So understanding this and utilizing this classroom copy, this homework, to your advantage, you're going to do great on the test. However, I'm not going to grade this homework just yet. I will have a homework check, but I'm not going to grade it for this chapter. Anyways, I hope you had a great day today. Keep doing what you're doing. I see a lot of great activity on Schoology, and I love that. If you have a question, please let me know, and you guys have a great day. Thank you.